Assalamu alaikum. My name is Benin Fatima. Today I present my presentation of organic spectroscopy, and the topic is AI-driven approaches in chemistry, recent advances and future perspectives. Content. Today we discuss in this slide their introduction and the history of AI, application of AI in various areas in chemical industry, AI in chemical research, their future and their reaction prediction, ML for predicting chemical reaction, the future of chemistry and the chemistry of the future, merging AI planning with robotic synthesis, discovery supported by chemical robots, AI for the synthesis and structure function relationship analysis, challenges and limitation, and the last one, their future perspectives. The next, introduction. Artificial intelligence. The term artificial intelligence was first coined by the father of AI, John McCarthy, in 1956, but the revolution of AI consequently began a few years in advance, such as 1940s. Research on artificial intelligence in the last 2 decades has greatly improved performance of both manufacturing and service system. In the 21st century, artificial intelligence has become an important area of research in virtually all fields: engineering, science, education, medicine, business, accounting, finance, marketing, economic, but we focus on chemistry. AI-driven approaches in chemistry have emerged as powerful tools, revolutionizing the way chemical compounds are discovered, synthesized, and analyzed. By leveraging the capability of machine learning, deep learning, and data mining, AI has enabled scientists to expedite research process, predict chemical properties, and design novel molecules with enhanced efficiency. Chemists have spent sustainable time on repetitive experimental tasks such as the synthesis of organic compound, optimization of process parameter, and molecular structure identification. To some extent, these tedious tasks limit the creativity of chemists. As green chemistry continues to evolve, the chemical industry has been working to discover new chemical reaction, catalysts, and equipment to reduce the use of hazardous substances and prepare high value added chemical through sustainable production process. Such discoveries are expensive and time consuming for pure human labor. In the past decade, a growing body of literature and patent attests to AI-driven chemical engineering studies. Bowen et al. Studied the growth and distribution of artificial intelligence in relevant chemical publication over the past 2 decades using the CAST content collection shown in figure 1. The number of published papers and patents containing AI driven has increased dramatically since 2015, with the second highest increase in published paper in industry, chemical and chemical engineering. Meanwhile, the data obtaining from SciFinder shows the total number of annual publication on machine learning in the chemical industry exceeded 20,000 in 21 to 22. These are graphs which show how dramatically increase of publication of patent publication in 2015 to onwards. Application of AI in various areas of the chemical industry. First, AI can be used for molecular structure function analysis, and the second most benefit of AI, which is they can reduce time or cost. Machine learning model performing molecular design tasks require only structural information of molecules or simple molecular property information, which are more readily available and accurate than experimental process. The successful application of artificial intelligence in areas such as image recognition and Processing has also facilitated its use in drug discovery, including the design optimization of small drug molecules. Key to the development of computer-aided chemistry is the availability of large reaction datasets and high-performance computing, for example in molecular design, retrosynthesis planning, reaction prediction, and optimizing of reaction condition. The last AL allow the automation of compound synthesis and reduce the repetitive work of laboratory staff. AI-driven approaches in chemical researches. AI-driven in chemical research has emerged as powerful tool for designing novel compound. Traditionally, approaches in chemistry often rely on time-consuming trial or an error experiment. However, with the advent of AI, researchers can now leverage advanced algorithms to rapidly explore chemical space, predict the properties and behavior of compound, and guide experimental design. One of the key advantages of AI-driven approach is their ability to extract valuable insight from large data set. By training machine learning model on vast chemical databases and experimental research, researchers can uncover hidden pattern, relationship, and trend that may be otherwise being overlooked. This enables them to make informed decisions and prioritize experiment, saving time and resources. The future of chemistry, no. What is the future of chemistry? No. AI has been around for several decades, like this started from 1940s, but getting better and better every day. Computer-assisted chemical synthesis was pioneered by E.J. Corey as back as 1985 when he reported in Science a very basic system for synthetic analysis in organic chemistry. This was 5 years before being awarded his Nobel Prize in 1919, but there was not a big flow up on this kind of chemistry until more recently. However, in the past couple of years, an explosion in computer-assisted chemistry is only getting started. This has been commented by J. Ferty and J. M.L. Brunel in 2018, but even since that day, many more recent work have been seeing the light of the day. This might indeed define the future of chemistry. Reaction prediction. AI is being increasingly used to expedite material discovery by predicting and optimizing material properties. Machine learning models can analyze existing material databases, predict properties such as conductivity, catalytic activity, or stability, or suggest new material and desired characteristics. This approach has been potential to revolutionize fields like energy storage, catalysts, and electronic materials. AI models can be analyzed reaction databases, learn reaction rules, and predict the product of chemical transformation. This is the potential to accelerate reaction discovery, optimize reaction condition, and facilitate the synthesis of chemical complex molecules. And the second major invention, that is holistic prediction of enantiomer selectivity. In 2019, Reid and Sigmund reported a groundbreaking report on the model for holistic prediction of enantiomer selectivity in asymmetric catalyst. This is the biggest achievement in organic chemistry perspectives. As we have stated in the introduction, a big part of a synthetic chemistry job is to scan the literature to select some reaction condition to test on a new substrate. This is clearly a job that well-programmed computers should do better than a human being, especially when there is 100 or 1,000 of possible conditions available. This is a field that Sigmund is pioneering, and awesome trends which allow for very significant prediction have already resulted from their efforts. Machine learning for prediction chemical reaction. As Joel Group explained on the website, machine learning, which is basically statistics and computer science, can be tool that will solve the problems of multi-dimensionally, which makes complex problem impossible for